sound of a dramatic, deep cellular hum then fades. Imagine a tiny, toxic dust slowly settling inside every cell of your body. These are the broken components, the misfolded proteins, and the accumulated lipofuscin, the wear and tear of a life lived. This cellular debris accelerates aging and invites disease. For decades, it was considered unavoidable. But inside you, a hidden, ancient process has the power to reverse this damage, actively seeking out and recycling the cellular junk. This process is autophagy, from the Greek for self-eating. It is not starvation. It is the fundamental mechanism of cellular survival and renewal. The evidence is now overwhelming, linking robust autophagy to extended health span, neuroprotection, and metabolic resilience. Today, the evidence edge reveals the precise time window protocols and the most powerful molecular activators you can use to force your cells to clean house. If you're serious about cellular longevity, hit the subscribe button now so you don't miss any of our evidence-based protocols. This is your 45-minute map to cellular reset. The scientific acknowledgement of this master recycling system is surprisingly recent. While the process itself was noted in the 1960s, it wasn't until 2016 that Japanese cell biologist Dr. Yoshinori Ohsumi was awarded the Nobel Prize in Physiology or Medicine. His breakthrough work, primarily using Baker's yeast, identified the essential genes that control autophagy. This discovery confirmed that autophagy is not a chaotic, random breakdown, but a highly regulated, genetically coded process that exists in nearly all complex life. It forced the scientific world to view self-eating not as an endpoint, but as a sophisticated survival mechanism, a brilliant form of internal triage and renewal that is activated under stress to protect the cell. To truly understand how to activate autophagy, we must visualize its molecular choreography. The process of macroautophagy unfolds in 3 core stages. It begins with initiation, triggered by signals like low nutrients. A crescent-shaped membrane, called a phagophore, begins to form. Next is elongation. Proteins like LC3 are crucial here, helping this membrane expand, reaching around the cellular components targeted for recycling. Finally, autophagosome formation. The phagophore completely encloses the cargo, sealing into a double-membraned vesicle, the autophagosome. This fully formed vehicle then travels through the cell until it performs the final critical step, fusion with the lysosome, the cell's recycling plant, where its contents are degraded and their molecular building blocks repurposed. The entire autophagy process hinges on the final destination, the lysosome. If the autophagosome is the transport truck, the lysosome is the powerful recycling center. This acidic, enzyme-filled organelle contains nearly 60 different types of hydrolase enzymes, capable of dissolving proteins, lipids, carbohydrates, and even DNA. The efficiency of this degradation is just as important as the initial encapsulation. If the lysosome is sluggish, a condition that increases with age, the autophagosome fuses, but the contents are poorly broken down. This leads to the buildup of partially digested junk, creating new toxic debris instead of releasing clean, reusable molecular building blocks. Therefore, a successful autophagy protocol must prioritize lysosomal health and efficiency. To truly enhance the final stage of autophagy, we need to activate the CEO of the cellular cleaning crew, TFEB or transcription factor EB. TFEB is a powerful master regulator that controls lysosomal biogenesis, the creation of new lysosomes. Think of it, you can trigger all the autophagosomes you want, but if you don't have enough functional lysosomes ready for fusion, the whole system jams. TFEB is normally kept inactive and sequestered in the cytoplasm by mTOR. When mTOR is inhibited, TFEB is free to travel into the nucleus, where it activates the genes necessary to massively boost the cell's capacity to degrade and recycle. This is the advanced layer of the protocol. We don't just want to start the cleaning, we want to build a bigger, faster recycling plant. Before we dive into activation, it is crucial to clarify that autophagy is not the cell's only cleaning system. Your cells actually possess 2 major trash disposal pathways. The first is the proteasome system. This is a small, barrel-shaped molecular machine responsible for breaking down individual, misfolded, or damaged small proteins. Think of it as the shredder for routine, daily, single-item waste. However, when the cell is faced with massive problems, like entire dysfunctional mitochondria, large clumps of toxic protein aggregates, such as those seen in Alzheimer's or pathogens, the proteasome is simply too small. This is where autophagy steps in. By sequestering the entire structure into the large autophagosome, it acts as the bulk recycling service, allowing the cell to handle objects far beyond the proteasome's capacity. They work in tandem, but when it comes to disease and agging, boosting the bulk clearance of autophagy is the priority. To access the power of autophagy, we must first confront its primary inhibitor, mTOR, or the mammalian target of rapamycin. mTOR acts as the cell's growth switch or foreman. It is a massive signaling complex that gauges the availability of three things: energy, oxygen, and most importantly, nutrients. When you consume protein and carbohydrates, the resulting surge in amino acids, especially leucine, and the rise in insulin from glucose forcefully activate mTOR. Its signal is simple: the environment is rich, stop repairing and start building and dividing. This is vital for muscle growth, but when mTOR is chronically active, a consequence of our modern high-frequency eating habits, it actively phosphorylates and deactivates the proteins required for autophagy. In essence, high mTOR puts a permanent brake on your cell's ability to clean and recycle. mTOR is the aggressive growth foreman, then AMPK, or AMP-activated protein kinase, is the survival strategist. AMPK's sole purpose is to serve as the cell's master fuel gauge. When energy levels drop, typically during periods of fasting or intense exercise, the cell consumes its primary fuel, ATP, which leaves behind the depleted molecule AMP. AMPK is activated by monitoring this spike in the AMP to ATP ratio. When this ratio is high, AMPK is powerfully activated, sending an emergency signal throughout the cell. Energy crisis, stop growing, start scavenging. Crucially, activated AMPK directly phosphorylates and shuts down mTOR. It is the most direct metabolic lever we have to halt the growth signal and switch the cell's resources toward repair, recycling, and longevity. Activating AMPK is the first major step in our autophagy protocol. Beyond the direct metabolic sensors of AMPK and mTOR, autophagy is intricately regulated by a complex interplay of hormones, forming a critical hormonal triangle. First, insulin. When you eat, especially carbohydrates, your pancreas releases insulin. Insulin's primary job is to shuttle glucose into cells, and it acts as a powerful activator of mTOR. So high insulin means inhibited autophagy. Second, glucagon. This hormone is insulin's antagonist. Released during fasting, glucagon signals the liver to release stored glucose. Crucially, glucagon also acts as a potent activator of autophagy through a separate pathway involving CAMP. Low insulin and high glucagon is the ideal state for cellular cleansing. Third, IGF-1, or insulin-like growth factor 1. This hormone, stimulated by protein intake and overall nutrient abundance, also robustly activates mTOR, thus inhibiting autophagy. Managing these three key hormonal signals through strategic eating is fundamental to consistently activating your cellular repair pathways. While nutrient deprivation primarily activates autophagy through the AMPK pathway, science has uncovered a powerful second route that is highly relevant to diet: the state of ketosis. When your body shifts from burning glucose to burning fat, it produces ketone bodies, primarily beta-hydroxybutyrate or /beta-HB. /beta-HB is not just an alternative fuel source for the brain. It is a signaling molecule with epigenetic power. Evidence shows that /beta-HB can activate autophagy independent of the direct AMPK-mTOR axis. It does this by directly inhibiting a protein called HDAC, which increases the transcription of autophagy-related genes. This means achieving deep ketosis, either through dietary carbohydrate restriction or through extended fasting, provides a double dose of activation: AMPK stimulation from the nutrient withdrawal, plus a potent gene-level activation from the /beta-HB signal. This makes the ketogenic metabolic state a uniquely efficient booster for your cellular repair program. Efficacy of fasting as an autophagy activator is entirely dependent on duration. It is a dose-dependent effect, meaning longer fasts yield a deeper cellular response. We can categorize this into 3 metabolic tiers. Tier 1, the metabolic switch, 12 to 16 hours. This is the window achieved by daily time-restricted eating (TRE). At this stage, you primarily burn through liver glycogen, leading to improved insulin sensitivity and initial activation of AMPK. However, true systemic autophagy markers are still low. Tier 2, significant basal autophagy, 18 to 24 hours. Beyond 18 hours, glycogen is largely depleted, the body shifts aggressively into fat oxidation, and ketone production begins. This is the starting point where significant basal autophagy is measured, focusing on routine cellular cleanup. Tier 3, maximal systemic autophagy, 36 to 48 hours. Once you push past 36 hours, you achieve the strongest response. This duration is associated with the maximal systemic clearance of long-lived protein aggregates and the start of deep cellular and even immune system regeneration. Knowing these tiers is essential for designing your personalized repair protocol. Autophagy is often discussed as bulk recycling, but the cell is far more sophisticated. It employs selective autophagy, processes that specifically target one type of organelle. The most vital of these is mitophagy, the targeted clearance of dysfunctional mitochondria. Mitochondria are the energy powerhouses, but when damaged by age or stress, they become toxic, leaking damaging reactive oxygen species, ROS. Mitophagy prevents this. The process is governed by 2 key proteins, PINK1 and parkin. When a mitochondria is depolarized, damaged, PINK1 accumulates on its surface. This recruits parkin, which acts as a molecular flag, tagging the failing mitochondria with ubiquitin chains. This tag tells the autophagosome, this one must go. By eliminating the old, inefficient power plants, mitophagy forces the cell to produce new, healthy ones, making it essential for longevity and muscle quality. This is critical because mitochondrial dysfunction is a primary characteristic of aging. We rely entirely on peer-reviewed evidence to bring you this level of biological detail. Subscribe and join our community of evidence-based thinkers. We have established that fasting is the single most potent trigger for autophagy. However, not everyone can or should fast frequently or for extended periods. This introduces the concept of calorie restriction mimetics, compounds that, when consumed, trick the cell into believing it is in a state of nutrient deprivation, thereby activating the AMPK and SIRT1 pathways without full food restriction. They are not substitutes for fasting, but powerful amplifiers that can be used to maintain a high basal level of autophagy or to supercharge the repair process during shorter fasting windows. These mimetics are tools that leverage molecular biology to create a persistent state of cellular repair, providing an alternative route for those looking to maximize longevity benefits. Our first core mimetic is spermidine. This polyamine is naturally found in high concentrations in foods like aged cheese, wheat germ, and mushrooms, but its levels in the body naturally decline with age, a decline closely linked to diminished autophagy. Spermidine acts as a direct, natural inducer of autophagy through a fascinating epigenetic mechanism. It inhibits an enzyme called histone acetyltransferase, or HAT. Think of HATs as molecular markers that typically suppress the expression of longevity and autophagy genes. By inhibiting HATs, spermidine essentially lifts the suppressive veil from these genes, allowing the cell to start producing the proteins necessary for its own self-cleaning process. Clinical and epidemiological studies strongly link higher spermidine intake to improved cardiovascular health and increased longevity in human populations. Our next cutting-edge mimetic is Urolithin A. This compound is a metabolite, meaning your body doesn't absorb it directly. Instead, specific strains of gut bacteria metabolize compounds found in pomegranates and berries, called L-argitinins, into urolithin A. What makes urolithin A exceptionally exciting is its specificity. It is one of the most potent known inducers of mitophagy. Clinical trials show its ability to selectively target and clear out old, inefficient mitochondria. This translates to measurable improvements in muscle endurance and overall physical performance in human subjects, particularly as we age. Because the effectiveness relies entirely on your gut microbiome's ability to produce it, urolithin A is a prime example of where targeted supplementation can bridge the gap between diet and optimal cellular repair. Rounding out our discussion of molecular activators are two classic compounds known for their broad longevity benefits, resveratrol and curcumin. Resveratrol. The polyphenol found in the skins of red grapes and various berries acts as a primary activator of the SIRT1 pathway, one of the key longevity genes. SIRT1 is a NAD-dependent enzyme that, when activated, signals the cell to conserve energy and promote repair, acting as a powerful upstream activator of autophagy. Similarly, curcumin, the active compound in turmeric, provides a multi-pronged approach. It is a potent anti-inflammatory agent, but scientifically, it also shows clear ability to suppress mTOR activity and enhance lysosomal function. When combined with fasting and other mimetics, these compounds create a robust, layered defense, ensuring multiple molecular pathways are engaged in the cellular cleanup process. Physical stress is a powerful, non-nutritional activator of autophagy, but for maximal effect, we must introduce the concept of glycogen depletion. When you perform intense exercise, like resistance training or HIIT, your muscles rapidly consume their stored sugar reserves, glycogen. If you perform this intense workout toward the end of your 16-hour fasting window, your glycogen stores are already at a critically low point. This creates an acute cellular energy crisis, causing the AMP-ATP ratio to spike dramatically higher than it would in a fed state. This intense, immediate energy demand acts as a massive emergency signal, forcefully flipping the AMPK switch to the ON position. This synergistic approach ensures the deepest level of autophagy activation, optimizing the clearing of damaged mitochondria, mitophagy, specifically within your muscle tissue. Our final non-nutritional activator involves applying acute, non-damaging stress to the system, a concept known as hormesis. The principle is simple. What doesn't kill the cell makes it stronger. Heat therapy, primarily achieved through sauna use, activates heat shock proteins, HSPs. These proteins act as cellular chaperones, helping damaged or misfolded proteins refold correctly and tagging those that are beyond repair for immediate autophagic clearance. They are essential partners to your cleaning crew. Conversely, acute cold therapy, such as ice baths or cold showers, forces the mitochondria, particularly in brown adipose tissue bat, to work overtime to generate heat. This high-intensity energy demand activates both the sympathetic nervous system and the AMPK pathway, providing another powerful systemic boost to cellular resilience and autophagy efficiency. Utilizing these thermal stressors strategically enhances your body's innate repair capacity. The most profound benefit of robust autophagy is its impact on longevity and health span. As we age, our tissues accumulate two dangerous forms of cellular junk. First, senescent cells, often called zombie cells. These cells are damaged and stop dividing, but refuse to die. Instead, they secrete a toxic brew of inflammatory compounds known as the SASP, senescence-associated secretory phenotype, poisoning surrounding healthy tissue and driving chronic inflammation. Autophagy, particularly the selective autophagy of damaged organelles, prevents the accumulation of the damage that leads to senescence. Second, lipofuscin, or age pigment. This is the brown, granular pigment composed of oxidized proteins and lipids that builds up primarily in heart, liver, and nerve cells. High levels of autophagy help clear this age pigment, literally reversing visible signs of cellular decay. By clearing both senescent cells and lipofuscin, you are directly addressing the foundational causes of age-related decline. Perhaps no organ benefits more profoundly from robust autophagy than the brain. Neurodegenerative diseases like Alzheimer's and Parkinson's are fundamentally diseases of poor waste clearance. In Alzheimer's, the problem is the accumulation of sticky amyloid beta plaques and hyperphosphorylated tau tangles. In Parkinson's, it's the aggregation of alpha-synuclein proteins, forming Lewy bodies. These are large, misfolded protein aggregates that overwhelm the brain's delicate waste disposal systems. The conventional proteasome simply cannot handle them. Autophagy, specifically the autophagosome, is the cell's primary and often only way to sequester, transport, and break down these toxic protein clusters, preventing their accumulation and the ensuing neuronal death. Activating and maintaining high levels of autophagy in the brain is arguably the single most important defense strategy against cognitive decline, memory loss, and the devastating impact of neurodegenerative diseases. Autophagy's benefits extend far beyond direct cellular repair, deeply impacting your metabolic health and immune resilience. In terms of metabolism, by clearing dysfunctional mitochondria and reducing cellular stress, autophagy significantly improves insulin sensitivity. When cells are clean and efficient, they respond better to insulin, preventing the onset of insulin resistance, a precursor to type 2 diabetes. This metabolic flexibility also reduces chronic, low-grade inflammation, often termed inflammaging, which silently drives many age-related diseases. For the immune system, autophagy is nothing short of revolutionary. It plays a critical role in eliminating intracellular pathogens like viruses and bacteria, and crucially, it recycles old, senescent, or exhausted immune cells. By clearing out these ineffective soldiers, autophagy allows for the generation of fresh, potent new immune cells upon refeeding, ensuring a robust and responsive defense system that can adapt to new threats. It's truly a systemic reset. Autophagy's role in cancer is often misunderstood, leading to the cancer paradox. We must distinguish between its preventative role and its survival role. In the early stages, autophagy is a powerful tumor suppressor. By clearing damaged organelles and faulty DNA before a malignancy can begin, it prevents the cellular errors that lead to cancer initiation. This is why maintaining high basal autophagy is a crucial long-term preventative measure. However, once a tumor is established, a rapidly growing malignant cell cluster, that same recycling mechanism can be hijacked. Cancer cells can use autophagy to scavenge nutrients during periods of high stress, such as chemotherapy or low blood supply, allowing them to survive and resist treatment. The clinical consensus, therefore, is clear: chronic suppressed autophagy is the greater long-term risk for cancer initiation. The goal is not to starve the tumor, but to maintain a high, steady state of cellular hygiene that prevents the tumor from ever forming. As we move into the final protocol, we must address two critical safety points. First, the major myth: autophagy causes muscle loss. The evidence is clear: short-term fasting, particularly the 16-8 window, does not cause muscle atrophy. Your body's priority is clearing damaged proteins and switching to fat burning for fuel. In fact, intense exercise in a fasted state, combined with the mitophagy benefits we discussed, can actually improve muscle quality. Muscle loss only becomes a significant factor during long-term starvation weeks, which is far beyond the scope of this protocol. Second, the critical safety requirement: electrolyte balance. Any fast exceeding 24 hours, especially those extending to 36 or 48 hours, necessitates rigorous electrolyte replenishment. Fasting causes your kidneys to rapidly excrete sodium, potassium, and magnesium. Failing to replace these vital minerals leads to the fasting flu, headaches, fatigue, and even dangerous heart palpitations. The goal is cellular repair, not distress. Always supplement with these key electrolytes and consult your physician before attempting any extended fast, particularly if you have pre-existing metabolic conditions. We have navigated the molecular depths of the cell, from the mTOR break to the TFEB master key. Now we bring it all together into the complete autophagy cellular repair protocol, the 7 steps you need to upgrade your cellular destiny. Step 1, the daily clock. Practice 16-8 time-restricted eating TRE daily. Align this window with your circadian rhythm, aiming to stop eating at least 3 hours before bed. Step 2, the deep clean. Schedule a 36-hour deep clean fast once per month for maximal systemic clearance and immune cell renewal. Step 3, fuel gauge workout. Perform high-intensity interval training, HIIT, or resistance training toward the end of your 16-hour fasting window to maximize glycogen depletion and the resulting AMPK signal. Step 4, thermal resilience. Incorporate acute thermal stress, sauna and/or cold plunges 3 to 4 times per week to activate heat shock proteins and mitochondrial biogenesis. Step 5, molecular support. Introduce core molecular mimetics like Spermidine and Urolithin A to maintain a high basal level of autophagy even during non-fasted states. Step 6. Electrolyte Foundation. Rigorously prioritize electrolyte supplementation, sodium, potassium, magnesium, during any fast extending beyond 24 hours. Step 7. Refeeding strategy. Break your extended fasts with clean, whole foods, specifically focusing on lean protein to rebuild, but avoiding massive carbohydrate spikes to keep mTOR from surging too quickly. Activating this internal repair mechanism is the most direct and scientifically validated control you have over your health span and longevity. This protocol gives you the complete map to unlock it. For the full protocol PDF, a list of all cited studies, and links to the highest quality molecular activators we discussed, click the link in the description. Take control of your cellular destiny today. Subscribe to the Evidence Edge now. Click the subscribe button and the bell icon so you're alerted immediately when we release our next investigation. Cold and heat therapy, the physiological stressors that supercharge your mitochondria.